Hello everyone and welcome to the opening session of Day 3 at Smart Lab Digital 2020, Pharma IQ's flagship digital event on the lab space, designed to help all of our attendees increase efficiency, enhance connectivity and drive superior quality as they take the journey toward the lab of the future. This session, a three-step interactive guide to executing a lab of the future, will be presented by two experts from Osthus, Chief Data Officer Eric Little and Head of Data Governance Dr. Heiner Oberkampf. Before we start, I have a couple of housekeeping points to raise. As this is an interactive webinar, you can send your questions for our presenters via the Q&A box on the left-hand side of the screen. Please include your name along with your question submission, and we'll aim to ask these questions following the presentation. Please make sure you click the submit button as well, otherwise we will not receive your questions. Also, you can resize all widgets on the page depending on the space on your own screens, whether you're joining us at home or in the office. So, with the housekeeping out of the way, it's time for me to hand over to Eric and Heiner to start the session.
Great, thanks a lot, Ben. So we're going to talk a little bit today about a three-step interactive guide to executing a true lab of the future. I'll go ahead and advance this. So our agenda is we'll introduce ourselves. We're going to spend a little time setting up the problem space. So where do we see the issues currently with what people call lab of the future and with the desire to get to such a state. And then we are going to lay out three steps that we have developed, which represent a proven methodology that can allow people to move towards a lab of the future and, in essence, digitally transform their entire R&D space in their company. These three steps will be based on focusing on data rather than tools and just processes and these kinds of things. Get the metadata right. It's going to be a central key component to what we're going to talk about. And then finally, we're going to talk about how you actually execute, learn, and iterate this. And we're going to give some examples of current projects and past projects that we've done with high success that have allowed people to move forward in these areas. So we'll start off with a quick introduction as to who we are. My name is Eric Little. I'm the Chief Data Officer at Osthus. I've been working in semantics now since the 1990s. I attended the University at Buffalo, where during my PhD work, I worked with Dr. Barry Smith and other people building the Obo Foundry, the basic formal ontology, and other kinds of semantic type systems. Since then, I've been an academic and I've worked in multiple fields in technology as a consultant and as a manager of tech companies. So I'll turn it over to Heiner for a quick introduction of himself.
Yeah, my name is Heiner Oberkampf, and I'm the head of data governance at Osthus. And my main topics are data integration and reference and master data management. And the key that we see with our customers and strategic projects that I'm involved in is that we take data really as an asset, and this has impact on how we manage and how we work with data.
Excellent.
Eric, would you like to continue?
Okay, yeah, brilliant. So I believe Ben is going to go ahead with a poll right now.
Yes, I am. So thanks, guys. Thanks for the introduction. The first poll question we have today, please make sure that you get your answers in, but the question is, how adept is your organization today at being able to find, link, and use data from across the organization? And we've got options there, so you've got extremely adept, all the way down to not adept at all, so you've got fairly, moderately, and somewhat. Please get your answers in, and while you're filling your answers in, what do our presenters expect to see here, Heiner?
So from our experience, we see that that people are somewhat adept, but that there are some advanced companies that have certain things already in place. So I think it's also depending on where you are in the organization, where you're more in the lab at the bench, or whether you are in the IT departments or somewhere else. Yeah.
Okay, and Eric, would you agree with that?
Yeah, it's a range depending on how much time and effort people have spent working in these problems. And we find that even sometimes the people who feel they're more adept, once we really dig in and get into more of the hardcore stuff, that people still find out that there are lots of gaps in their understanding of these things. So it's always good, though, to know the audience and to know the level of the people that we're talking to.
Okay, brilliant. So let's find out what our audience has said. Ah, very interesting. So we've got majority of people saying moderately or somewhat adept. We've got 36.7 on both of those there. I guess that's kind of in line with what you guys were saying, but are you surprised by anything you can see on the results there?
No, that's the normal bell curve.
Okay, perfect. All right, I will leave you guys to carry on the presentation. Thank you.
Okay, excellent. Great. So what we're going to do then is we're going to take these answers and hopefully by the time we're done with this discussion, some people at least are going to understand some areas where perhaps you can focus some of your efforts and improve the ability to really be able to find, link, and use your data in your organization. So to start with, we wanted to talk a little bit about this concept of lab of the future. So there's a lot of talk about this at a lot of conferences. There are a lot of people who claim to be doing this. But when you really dig into a lot of what people are saying when they talk about lab of the future, you get into a lot of discussion about robotics and automation. People talk about fancy AI concepts. People talk about smart machines. I know many customers are working on wearables, so this can reduce login times in the lab and reduce lots and lots of keystrokes. There's a lot of hype, and people love to see the pictures and the videos about all the augmented and virtual reality tools, so the kind of fancy Google Glass things or lighting up the items on shelves that you might need for a given formulation. But our question really is, even if you put all of that fancy tech in place, you still have a lot of other tech that has been around for decades and will continue to live beyond the next couple of years. So the question that we have is always really, what about the data behind all of this stuff? So adding in more kinds of data producing devices with different kinds of formats, fancier algorithms or new kinds of image-based data or video-based data, it's really not helping the core problem. If you can't manage your data in general, adding more kinds of data and increasing the variety of that data is really not going to help. So there's an interesting paper that was published in the International Pharmaceutical Industry Journal of last year in 2019. And we kind of wanted to highlight some of these points because it really brings to the surface, I would say, the topics that we want to talk about here. So we'll all, I think, agree that many challenges exist within laboratories. So the key to this is really a lack of architectural thinking. So there's a lot of people out there who buy several kinds of ELNs, several kinds of LIMS systems, but these things don't really fit well in their architectures, or they buy them, they load them with data, and then they find out that they're not as interoperable as they were hoping. And part of the problem here is that you're really combining a lot of new and old technology together. So we see many customers with, for example, multiple LIMS systems, but the data inside the LIMS systems gets captured in completely different ways. One LIMS system will be completely numeric, one LIMS system will be alphanumeric, and then you can have the same item mean and get labeled two different ways in these two different systems. And now you have to try and homogenize this when you go to extract the data in querying or to do some kind of an analysis. And this is normally where the problems start to occur. Another issue that this paper points out that we agree with is that there's a lot of heavy customization of products that happens. So a lot of people buy these tools, then they realize they don't really fit their needs. So they go about with their IT group or with some consultants or something to really customize these products for what they want to do with them. But again, the more you customize this code, the harder it can be to move and migrate data, the harder it can be to get data out and align it to another system. And that causes a major challenge. And a lot of companies spend an awful lot of money trying to integrate these systems, and it's a long, painful process, and it's done in a very step-by-step, slow kind of fashion. The last thing we see is that upgrades are often delayed. So a lot of people buy a system, they like it, and then they don't want to change it very often, or they have company policies that only allow them to update their software, 1 or 2 times a year. And so then your software can fall behind. The vendor you bought it from now may say, oh, well, we're on a different version. You have to make sure things are backwards compatible to the older versions you might have, and so on. So the important foundational pieces that we see that help to remedy this is, number one, you have to start by thinking about your infrastructure. And by your infrastructure nowadays, given the landscape of how pharma companies look like from the business side, it's not only you, it's you and all of your partners. So this might include a whole host of CROs that you work with that are handing you new compounds or are handing you their research material, and it's in an incompatible format, or they have a different ELN or a different LIMS system than you use. So now, again, you have this problem multiplied. Not only do you have the problem inside of your labs and your company to integrate the data, you've got this problem of integrating across multiple people's sites. Storage and archiving is another big issue. So the idea that you just lock this away can be a problem. The master data management piece is key, and standardizing practices is another really big part that we bring in from the semantic side. And then finally, you have to think about how you're going to maintain these systems over time. So the numerous markets are telling you basically that the data really matters. I'm not going to bother to spend a lot of time on this, but basically a lot of companies are trying to apply things like machine learning and a lot of fancy decision-making software, and they're replacing some of their consultants, but they realize that they don't have the data that makes it work. So again, it's all about what's underneath the hood that matters. This is kind of a slide we put together because I think it's something that a lot of people who've looked at labs will agree that every day in laboratories, this kind of discussion happens where someone says, well, what experiments did we already run on this substance, and do we know where the data is, and can we access it? And someone says, not really. It's probably easier to just run another experiment. So that can get quite expensive, and basically you're just producing more and more data now that's duplicated with stuff that you already had because you simply couldn't find it in the first place. So we're going to break this down now into our 3 steps. The first step is focus on the data. So if we're going to focus on the data, our argument is that you need to change the way that you think about data in general. So first of all, how do you store data? Is it stored in a tabular way? Is it stored graphically? Is it some combination of the two? Do you have different systems that do it in different ways? How is it accessed? Can you get at the data? Can you query it? How does it get used? Does it align with the workflows and the processes that your people actually have? How do you share it? How well is it even understood? A lot of times we get customers who really don't even understand not only where the data is, they don't really understand what it's all called or what different people call it. So that makes it even harder to exchange information. And then how well can you communicate with it? So how well can you actually pull your data out, put it in a report that means something to someone on the business side so that they can understand maybe a go, no-go decision, or they can try to understand which thing they're going to pick. So you have to really think about combining the business assets and the data assets. So on the business side, you've got things like people want to talk about quality and compliance. They want to orchestrate resources. They want to drive informed data-driven decisions. They want to identify the new business opportunities, and they want to shorten cycle time so that you can be more efficient. But on the data asset side, you want to really think about how do you regain control of terms and what the data means? How do you create an overview of the assets? How do you ensure accuracy and consistency? How do you organize that data for future use cases? And how do you build integrated architectures that allow this data to come together? This gap is huge, and this gap is something that if you do it right on your data side, again, you can start to build better bridges and stronger bridges between the business side and the lab side or the R&D side of your organization. So what data do people really need to make better decisions is key. And that's something that you get through, use case development, talking to your experts, and really understanding the problems. So if we move then to
one slide back, Eric, just to add here maybe, and if you go back to that slide, the users are really different types of people. So this can be people in the lab, this could be data scientists, could be people from the business, can be actually even the patients. If you think about that pharma companies are moving to more and more digital products that that makes them very much closer to the patient, where, for example, patient-specific medication, getting the right drug at the right time to the right patient. And having this user focus is essential to address the needs of the people and to create value with data.
Yeah, that's a great point. That's right. It really is. It really does come down to who's using it for what and how. That's right. So if we move ahead to our step 2 that we have, the issue here is to really get the metadata right. So if we think about what that means, this picture to me is always kind of important, because what it shows is the ability to leverage your data across, whether it's labs, R&D, move it over to manufacturing, use it for QA, QC, whatever. The idea here about getting your data right and using the metadata to help steer that is that this middle picture here has a what you might call an ontology model, a metadata model. It's graphical because that's the way people think about associative data. So we think about how data is related. We think about data more in terms of nodes and arcs than we do in terms of tabular lookup, the way it exists, for example, on the right-hand top side in structured data sources. So the idea here is that it doesn't really matter what kind of data you have, whether it's structured, whether it's semi-structured, or whether it's unstructured. So down in the bottom left corner, you see some text analytics. All of this needs to align to common concepts, common relationships, and common entities. And if you get that right and you're able to align all of these kinds of data sources correctly, then you wind up with, on the bottom right-hand corner, this analytics piece. You get a combination of your logically organized data, as well as all of your math-based approaches to data science and your algorithmic approaches to bubbling up data. And what you're able to do is you're able to actually make search and analytics that matter, search and analytics that make sense and that people can use, because you've got this common anchor point between all of your data systems. So for us, part of getting your data right in the first place is then, once I understand what it is, how I organize it, how I model it, and how I connect it is what becomes really, really critical. So I'll turn over to Heiner now a little bit to talk some about the actual structures behind some of this.
Yeah, thank you, Eric. And what you see here now on the slide are 4 critical or important data structures. And it starts really with a data catalog or data inventory. And this comes from the thinking of managing data as assets. So this is an overview of all the different data sets and databases, source systems, etc. that you have, and compare this with the management of financial assets. It's very clear that a company needs to manage these assets as a critical thing, because cash flow is critical. If you think in data assets, the situation is very different at the moment. Most of the companies still have no real overview of what data assets they have. And our job is often to bring companies into the situation that there is this clear overview of all the things. And that is the basis to start steering how assets are managed. Part of that is the data models that are specific to certain sources, but also harmonized data models that allow you to answer questions across multiple data systems or data sources. That's what Eric explained in the slide before. That is the view from the business, for example, that can answer questions like which products do we have for certain indications, or which substances have we analyzed already, or which experiments have we made for different materials. And the crucial thing is that you combine the global view on data with certain business perspectives that are needed in specific applications. And the underlying assets that you see here is the reference and master data and data alignments. And this is critical that you manage the terminologies, the code lists, the taxonomies, etc., right? Because they are used across many different data assets, and they ensure that you can actually combine data during analytics time. So the alignments between this and how you manage these are critical for data integration. And there's a spectrum of ways of how you can organize knowledge that ranges from very simple lists up to ontologies. And Eric, would you like to move us through the spectrum?
Yeah, sure. Thanks, Hunter. So if we think about how you want to bring your data together and how you're thinking about organizing it, one of the keys is to really have the end state in mind. So understanding both where you are and where you want to go is critical here. So at the lowest level, you can organize your data in lists. It's like a shopping list. It's just you write down the things that you want. It's not alphabetical. You don't write it down according to where you're going in the store. It's just the things you need to pick up. And oftentimes we see a lot of data, especially in file stores and things like this, simply put in as lists. If you move
or for example, drop downs in your application menus, or something that a list of methods, a list of countries, etc. Very easy things. So.
Right, exactly. If you move forward from that, you get into an informal hierarchy, which is maybe you organize lists somehow, and you can think about this as like, you know, the way that file systems can be created. So SharePoint gives you an informal kind of a hierarchy, which we call a weak taxonomy. Nothing is really inherited by making something a subfolder of something else. It's simply you make a list now that is accordion, so you can basically open and close it, make it more or less explicit. If you move up from that, you can eventually get into thesauri, and with a thesaurus, you have the ability to at least say that terms have broader or narrower meanings than other things. So you can say something like mammal is broader than canine, or canine narrower than mammal, or you can use synonyms for things where you can start to talk about, okay, these different terms all point to the same kind of concept. And then you'll notice that there's this line, this dotted line in the middle. And when you cross that line, you actually start now to move into real formal semantics. So everything below that line is a really, really base level kind of an organization of data. But once you move over that line, what that line represents is logical import. So when you get to a real taxonomy, which we're calling a formal hierarchy, the fourth thing up on the line, now you actually have is a relationship. So you can actually say now that canine is a subclass of mammal, and that means that the properties of canine would be inherited from the properties of its superclass. So mammals have fur and live birth and these kinds of things. So anything that classifies under that as a feline, canine, etc., inherits those basic properties of its superclass, and then you can start to differentiate more. So you actually can say more expressive things now, and this is the value of taking your terms and your list and actually putting them into a logical first level of organization, which is a taxonomy and acyclical tree graphs that give you the ability to at least move up and down. From there, you can start to build out things like conceptual models. Conceptual models give you basically the ability to talk about classes versus instances of things. You can start to add in properties on those things. You can talk about cardinalities, like how many exist of this? Is it only one? Is it more than one? And so on and so on. So you can now start to really put shapes and some even more complex modeling around your information. And what you've done is you've broken out of being able to just move up and down in a taxonomic chain to being able to move across. But conceptual models still, in this way, can be a little bit more lightweight than a full-blown ontology. An actual ontology adds the most amount of logical import. So an actual ontology in something like OWL or first-order predicate logic or something like this, description logics, whatever you'd like, you actually can now put things like constraints on classes. You can now define relationships in very specific ways where they can be one-sided or mutual relationships. You can start to put rules and these kinds of really logically governing principles on the model. And at that point, it becomes extremely expressive. But the key is, because it's very rule-based, because it's very ordered and structured and logical, you now have a model that is both human and machine readable quite easily. So this is where the value of this comes in, and where it starts to extend into how you can use these models for other kinds of systems, moving into like machine learning or AI or these other areas. So, Heiner, would you like to go ahead and explain some things about governance then to everyone about this?
Yeah, and just maybe a very short thing to add here. You see that this ranges from weak to strong semantics, and as Eric explained, you can do more the higher you go here. But it's also, the complexity is higher, so the effort or the knowledge that you have to build that is also increasing. So for some use cases, lists are really the best thing to do, and for others, ontologies are the right thing to do. You just need to know when to do what, and this depends on the use cases.
Yeah, that's a really good
point. Governance is something that is even one level higher. So here you see that metadata is just one aspect that is related to it, and that there are a lot of other aspects to it, like data quality or reference and master data management, data storage and operations, etc. And all these different things together, the rules and how you address these different categories, that is what we call this data management as assets in order to support business goals. And many companies are starting their journey on data governance also in the lab domain, such as CMC or something similar. And what you then start thinking about is, how do you start this? And execution and learning and iterating fast is key in this. So we'll walk you through some of our experience in large projects. Yeah? So the general approach that we take, you can see here on this picture, where we come bottom up by analyzing the business processes. So for example, here this is from chemistry, manufacturing, and control, where you have different sub-processes, like in chemistry and analytics, the formulation, etc. And we analyze the different applications and the questions that are answered in these different applications. And from this process understanding and mapping, we identify the key business entities or data elements like compound, batch, experiment, etc. That are reoccurring across different processes. Yeah? And this gives us a clear picture of how data is used and how data is flowing between applications. And this as-is understanding is very important in order to not create a project for which then there is no data available. But on the other hand, you have specific questions that you want to answer. Like, for example, get me all experiments for a certain material or for a certain substance. Or clarify a question, how similar are certain batches. And this is the top-down approach, where you start with an integrated data model that is able to answer these questions. And then the challenge is in how to map and align this so that you can answer the top-level questions with the real data that you get from the business processes. And the approach here is really look at specific use cases, at specific business questions, specific business processes, so that you start solving a problem already at an early stage of the project, and that you are ensuring that you're actually creating value that helps the business, and to invest in further analysis and extending of the data model, etc., so that it's not just a technology or a data modeling exercise, but that you can answer real-world business questions. Another aspect that I want to highlight here is that we always think in MVPs. So something that you can use in production. And as you see here, I've written MVVP, and actually 3 Vs. And for those who don't know this concept, this is inspired by Gui Kawasaki. And the thing is that we're not only putting viable products in your environment, you also need to think about the value of what you set up, so that you avoid having just a tech push and installing a data lake or some other technology that is viable but that has no value as if it's only technology. And the third V is validating, and this means that you ensure that by creating this MVP, you test your strategic questions. So the breakdown of your digitalization strategy has certain aspects that you need to test, because digitalization is an unknown territory for most of the companies, and they have certain hypotheses of how the future work is organized, how the future products will look like. And with the MVPs, you're validating your assumptions and you learn. Eric, would you like to add anything here?
Yeah, so I think that this is a fairly simple explanation and diagram, but I really think that this is one of the areas where we see a lot of customers struggle. And the reason is because when they think about data science or they think about machine learning principles, anything that's algorithmic, mathematically driven, it tends to be a very bottom-up approach. And so it's very good to start with your data and drive your data, but then when people start thinking about metadata, about ontologies, about semantics, that's, as Heiner's showing here, is very much this kind of top-down approach, right? It's very much a logical model of what you're looking for, and people have a tendency to overbuild those models then sometimes, and there's not always good data underneath. So we've seen a lot of customers spend a lot of time building classes and relationships and very big fancy models, and then they don't really have the data that aligns. The instance data is not there to fill that out, or they start with a lot of instance data and they boil a lot of items up, but they don't really have a good logical structure of how those things fit to the actual questions they want to ask and such. So the important piece here is you have to do both at the same time. We published some things in the past where I've called this the informing constraining relationship. So the ontologies from the top down really inform you about how you're thinking about the world, what the data means, what the questions are you want to query and ask, and the analysis you want to run. But the constraining part is you have to have connection to the actual data there, and you have to figure out how to actually tap into that data. So working in this middle space and understanding this from a multi-dimensional perspective is, I think, what's really critical to building a good MVP kind of product like Heiner's describing. So,
yeah. And so what you see here on the right are a couple of strategic projects that we are doing with leading companies. And this webinar is too short to go through all of those examples. If you are interested in specific of these projects, then just get in contact with us and we can go in detail into through those projects and explain you what was key in realizing that. But as you see, they range really across different areas in pharma. Many of those are either the basis of transformation or they are actually defining the strategy in the digitalization. And they all involve aspects of business and IT requirements. And this is a key role that we take, is that we not only bring in one side, but that we actually bridge business and IT, similar to what Eric explained with the business assets and the data assets, and that is key in order to be successful. One example from this list, the digital integration backbone, I would like to talk about in the next slide. And here, the customer we're working with said that integration projects are repeating across in different across the enterprise, but that they need to have or build their integration capabilities so that cross-project synergies can be leveraged. And putting these technologies like event streaming, data virtualization, data lakes, or data aggregators in place is one thing, but educating the business on how to utilize this in a collaborative and supporting way, that is the challenge, and that's what we're addressing with them. So defining, for example, guidelines or best practices so that people can learn from what has been done already. And things like the catalog or reference master data management, data model repositories, persistent identifiers, etc. These are all supporting things that lower the cost of data integration. And Eric, maybe you can explain this a little bit about on different use cases that you worked on.
Yeah, so this is the next two slides. What we're going to do is we're going to actually show you a proven methodology that we use in how we get to this understanding. So as Heiner talked about, we start with business processes. We always start with the perspective of the customer and what they're trying to do. So one of the best ways to kick off something like this is to really start in a workshop mode. And this is an example of what we normally will pull out in these workshops. You'll see on the left-hand side, we normally just ask people, okay, what are the use cases? What are the things you want to do? So someone may say, well, I want to do batch comparisons, or I want to make some kind of a report, or some type of an analytics, or I want to test purity analytics, or I want to know my whole product genealogy, right? These kinds of things. And then what we do is we have the users actually describe what that use case is. And then the important part is the third column, the current bottleneck. So that question is really simple. Why aren't you doing this right now? What's holding you back? And oftentimes it's something like, well, the data doesn't exist. We don't have access. The data is disjointed. It's laying all over the company and we can't integrate it, or we don't have the expertise or whatever. And so from this approach, you start capturing what the customers want. And some workshops, we may get 13 of these use cases like this. In some workshops, we've gotten over 80. So the question you don't want to stop people from spitballing these ideas. You want to let them throw out everything. I have a very simple question for people when I start. If I was to start putting easy buttons on the table in front of you, what do they do if you push them? It's that simple. Like, what do you want to do? And once you get these things captured, then the important part is you want to start to plot them. So by making a quad chart like this with a y-axis of benefit and an x-axis of time, effort, and difficulty, again, we don't build this for the customer. We sit in the room with the customer and we force them to start to say, okay, let's take one of these things, purity analytics. How valuable is that to a company? That's pretty valuable. It's about an 8 out of a 10 on this one. It turns out 13 is really high. So broadcasting substance results was a big deal to this customer. And what this showed is that these items here have high value to the business on the left side of the model, and they're pretty easy to accomplish. So in fact, this customer realized after this workshop that they could do 4, 7, and 13 themselves. They didn't even need us or need the semantic system in place to do this. We just identified some key areas that they could start to tackle with their IT group right away. The things that were a little bit more complicated are represented here in this box. So here you can see they wanted to do maybe summary reports, which batch comparisons. Now what you can do is you can start to look at these kinds of things as quick win projects. So what are the things you can do right away that could get you value? And that's a key component. You have to show value. And if you start to stitch these together, you could say, okay, we could build a roadmap and go from 2 to 1 to 3 to 8 and maybe out to 5, which notices that product genealogy. That's kind of a holy grail kind of thing. That's going to be a couple of years out on the timeline more than likely, right? Or at least many months. So the key here is this helps someone to organize those use cases and to give them a roadmap they can take to their management and say, look, if we start here, here's some of the results we could get right away, and we can start to build off of these successes in the following ways. And by the, you can start to then put this in a timeline by quarters and see where you're going to be in 3 months, 6 months, 12 months, 18 months, and so on. So if we look then at some of this in action, I'm going to show you a couple of real-world use cases where this has been very successful. This is an example from a medical device company I worked with some time ago. And basically, these people had a very big problem of they had a lot of data in a lot of different systems. So they had lots of different limbs. They had instrumentation. They had all this R&D stuff. And they had a lot of documentation. The problem was to build a report for an external regulatory affiliate meant that this person in the middle had to basically manually start up here in the left-hand corner. So they had to go and do a protocol search to get the lot information. From that lot information, then they had to go into all of these different systems, and sometimes they couldn't even access the systems. They had to go to different people, different SMEs, different technologists, to actually have them interrogate their systems. And to get this answer back to send off, normally by the time they got it back, it was incomplete. They didn't have everything. Not everyone understood what was supposed to be queried, or the data didn't exist, or it was dirty, or they couldn't find it. And so the thing is that normally they would get is it verified? No, they get to go back right to this initial step of protocol search and do it again. This process took 5 to 6 weeks to complete a report for regulatory. Once we connected all of this information using a semantic-based system with over 30 ontologies stitched together in a very large cloud, private cloud application, we brought this process down to an automation where it could pull this all together in 12 to 40 seconds. So we moved from 5 to 6 weeks to 12 to 40 seconds. And the report that came out was 100% verifiable, and it could be validated. So there weren't a lot of these errors that you saw previously when it was more manual. The second example will show you some work that we've been doing in omics data. And so there's a lot of people nowadays that are really looking at, okay, well, it's one thing to integrate my internal data. How do I integrate my internal data and then go fish for external data in the open source world? And so with this, you'll see that people may be interested in looking at peptides, or maybe looking at biomarkers or genomic signatures. And they want to see, okay, well, how novel is this thing I'm looking at? Is there anything out in an open source area like NextProt or SemMedDB or one of these other open source areas? What's being published on it in PubMed? And so what they want to be able to do is not only bring their data together, like their lab data, their patient data, they want to go out into the open source world. And again, understanding, can you fulfill those queries? Can you bring this back? Can be the difference between opening a research avenue or not. So these are two examples of how we've applied what we're talking about in real world activities. And I'll just turn it back over to Heiner now to kind of wrap up on some more of these specifics.
Yeah, I mean, this is, so we didn't have so much time left. This is just an example of a very strategic project. So here the customer planned to invest 40 million over the next 3 years. So each year, 40 million. And we designed the architecture and prioritized the use cases as explained by Eric, defined the target architecture, the operating model, assessed the as-is maturity, and discussed where they want to go with data management maturity. And this is a advisory document that came out of that, so that a company can make the right investments decision with their large budgets. And a key aspect in this that is shown here on this slide is that a change from the application-centric world to the data-centric world. And the difference is that applications just work with the data, but they don't own it. As you see here, the data is in the center, and the applications interact with the data that is connected, but they don't bury that in their silos. And I think this shift is important. Still, a lot of these systems own the data, and it's very difficult to extract it. So when you design new architectures and design new systems, then thinking in this way of putting the data in the middle and ensuring that all applications have access to all data is key for future readiness. And with that, I think we should jump into the Q&A session.
Yeah,
Ben, do you lead this?
Yeah. Yes, I'll lead this for you guys. That was a fantastic presentation. Loads of information in there, and we're starting to get some really good questions come through. Please feel free to send your questions in to us before we finish. We've got a few minutes for questions. So we've got a great question that's just come in. So we've had a question from Paul. It says, we are often reliant on scientists to manually enter metadata, which represents extra effort for no immediate benefit. Do either of you have any strategies to improve the quality and quantity of metadata, which is reliant on user input?
Eric,
yeah, I'll start with this. One of the things so first of all, Paul, you're 100% correct. So making people enter pages full of metadata to enter their regular data is not going to work. So people just simply ignore the systems, or they just put in the date timestamp and like the machine they're using in the lab or something like that. They ignore a lot of the other things. So you don't want to overly burden your scientists with having to add in all this metadata. Instead, one of the things you can do is we have some tools and some techniques and some products basically that we've built to help align these processes and to actually automate this. One of the things you can do is you can actually pull metadata directly off of instruments. You can pull metadata directly out of other systems, and you can provide a way to help to automate these processes to take the burden off of the end user. So I don't have time to get into all of that right now, but this is a topic that we've seen over and over again. And Ostis is working very hard with certain people to help basically mitigate the amount of manual effort. So I'd be happy to take this offline and we can have a call and discuss how we're doing this with folks.
And of course, we'll share every question that's been asked as well with you guys afterwards. So hopefully, if you've got your questions, do get them in, and we'll share them with the team afterwards. We've got a question here from Jessica, who says, "What type of people or skill set do we need on the customer side to take over and manage these kinds of technologies presented?"
Eric, can you take that?
Sure. So normally you have two choices. You either buy people or you build people. Those are your options. So you can go out and try to find people who have backgrounds in semantics or data science, but we all know that those people are very, very hard to come by. Normally what I recommend to customers is to find the people in your organization and build them. That means that you may grab someone who is an architect. You may grab someone who is good at running your relational databases, or people who understand about building your data lake, or people who understand about building your data warehouse. Those people who have a technical understanding of data and of schemas can be trained up in semantic thinking. And normally what we'll do is we'll come in and we'll do some consulting with these people, and we'll teach them a little bit about, instead of thinking about the data in a tabular way, we teach them to think about it in a graph way. We teach them, instead of writing SQL queries, how to write Sparkle queries. And in this sense, what you're doing is, normally through an engagement with a customer, we are building up the expertise inside the customer. And we've seen this work at several of our clients, where they've then gone out and started to hire other people from the outside, or they've just transitioned people on the inside to be able to fill a bunch of these important roles. So in that sense, our work starts to lessen. We work more on the heavy-duty problems, and we work with the team inside the company that's learning and learning and learning. They start basically with a grade school, then they get the high school level, and they get the college level, and then eventually they're grad student level, and they can handle most of it. But there's a process of building these people up, because frankly, these resources don't grow on trees.
Okay, brilliant. That's a good answer to that. We've got time for probably just one more question, as we've got another session starting soon. But we've got a question here from Willie, which I think is a really interesting question. He says, the use case you showed, where you get from 5 to 6 weeks to 12 to 40 to create a report, how long did it take you to, 12 to 40 seconds to create a report? How long did it take you to get this done, and how much did your customer pay for it? And I'll leave that one open to either of you there.
I can take this
question
one.
for Eric again.
Yeah, sorry, Heiner. So this project to get to completion without the extensions was about 10 months. Realistically, with everything finished, it was about a year. The cost back then was much higher because this customer chose to buy a private cloud. So they bought, over the course of that year, around $400,000 just in hardware. Now that we have public cloud like Amazon and such, you don't need that. So basically, what I would recommend is you're looking at probably a 6-month to 12-month project, and I would say it's going to run somewhere $500K and up. So that customer, again, paid more, but that was around 8 or 9 years ago. So prices have gone down now with computing. But I will warn people that there's also a trick to doing this in the public cloud sphere. So using Amazon and Azure is not a silver bullet, because if you're not careful on how you are using these data models, if you're not careful how you're using your ontologies, you can wind up pulling a lot of information into in-memory models, and you get charged for that transaction. And you get charged for the size of the server you need to hold that in-memory model, and they may start spinning up machines on the back end. So it's not uncommon for people I'm talking to nowadays within the last year or two to tell me that they've had to turn systems off because someone ran a query that cost them $50,000 plus. So there's ways to mitigate that as well. And again, if you contact us, I'm willing to have an offline conversation about this. We have a lot of strategies for how to improve this and how to help people, do this in the most economical way possible.
Okay, brilliant. Okay, so I think we're going to have to wrap it up there, but thank you so much, guys, for a brilliant presentation and some fantastic answers at the end there. With that final answer, I think we've come to the end of our first session today, so thank you both to Heiner and Eric for a really insightful presentation. This session will be available on demand within the next hour, so please do share it with any of your colleagues who perhaps weren't able to join us. We hope to see you in approximately 9 minutes when our next session will feature the University of Southampton's Jeremy Frey, and he's going to be talking about how we can break down barriers to a truly connected lab. So please do join us for what should be a fantastic final session to Smart Labs Digital 2020. And thanks again to all our attendees, and we'll see you again shortly.